sugar.
Hi guys, welcome to my YouTube channel. This video is all about the final project in logic circuit and switching theory entitled combinational circuit. This is circuit design A and circuit design B. So you can see circuit design A, the output Y is light on, and then the circuit design B, the output Z, the bulb is lights off. These two circuit design I will explain to you later. First, I will introduce the materials that needed in this experiment. The materials needed in the experiment circuit A and circuit B are: first is the AND gate or 74S08 IC. There are two pieces used. The second one is the inverter 74LS04 IC. Then there are two pieces inverter used. The third materials that needed in the two circuits is OR gate 74LS32. There are two pieces OR gate are used. Then the fourth materials is battery 9 voltage, two pieces. Then the fifth one is the LED, two pieces, color green. Six materials is the resistor. We needed 10 pieces resistor in our two circuits. Then next, the breadboard, the seventh materials breadboard, two pieces. We need two pieces. Then the eighth is solid wire, 3 meters. We need 3 meters in the two circuits. The ninth materials is the dip switch. So we need 5 inputs. So 1, 2, 3, 4, 5. Then the last one is the 10th materials that we need is the battery clip. We need two pieces. After introduce the materials that are needed in the experiment in circuit design A and circuit design B, so let's proceed the problem actual scenario. So this is the problem that we need to find a solution. So the problem actual scenario is a flow rate sensing device used on a liquid transport pipeline function as follows. The device provides a 5-bit output where all 5 bits are 0 if the flow rate is less than 10 gallons per minute. The first bit is 1 if the flow rate is at least 10 gallons per minute. The first and second bit are 1 if the flow rate is at least 20 gallons per minute. The first, second, and third bits are 1 if the flow rate is at least 30 gallons per minute, and so on. The 5 bits represented by the logical variables A, B, C, D, and A are used as inputs to a device that provides two outputs Y and Z. The first question, A, write an equation design and develop a circuit for the output Y if we want Y to be 1 if the flow rate is less than 30 gallons per minute. B. Write an equation, design, and develop a circuit for the Z if we want Z to be 1 if the flow rate is at least 20 gallons per minute but less than 50 gallons per minute. So let's proceed the solution in this problem. So this is the answer of equation A, Boolean function simplification. So in this Boolean function simplification, I use the minterms, the canonical and standard forms. The canonical forms is a Boolean function expressed as a sum of minterms or product of max terms. So in the answer of question A, I use the sum of the minterms. Sum of minterms is a Boolean function may be expressed algebraically from a given truth table by forming a minterm for each combination of the variables that produces 1 in the function and then taking the OR of all those terms. So in the problem, there are 5 bits. The device provides a 5 bits output where all 5 bits are 0 if the flow rate is less than 10 gallons per minute. So the first bit is 1 if the flow rate is at least 10 gallons per minute. So my first bit is the letter A, the letter E, my first bit. Then the first and the second bit are 1 if the flow rate is at least 20 gallons per minute. The first, second, and third bits are 1 if the flow rate is at least 30 gallons per minute, and so on. So A is my first bit, D is my second bit, C is my third bit, and B is my fourth bit, and A is my fifth bit. So, so in the truth table, you can see if we set the all inputs to 0, the output Y become 1. Then A is 1. Then D and A is 1, and C1, D1, AD, and B1, C1, and D1, and A1. So A is 1, B1, C1, D1, and A is 1. So the output Y is in the 1, 1, 1, 0, 0, 0. So the minterms is A bar, B bar, C bar, D bar, and A bar. Then next is A bar, B bar, C bar, D bar, and the A is not bar. Then next is A bar, B bar, C bar, D and A bar, B bar, C, D, E, A bar, B, C, D, E, then A, B, C, D, E. In Boolean function simplification, I use the sum of minterms. So you can see the simplification. This is the circuit design B, the Boolean function simplification, the sum of minterms, and the truth table. A first bit, D second bit, C third bit, B fourth bit, and A is fifth bit. A, B, C, D, E. Oh, A, B, C, D in this is the inputs, and the Y output is the G. So the minterms is the same in the circuit design A. So this is the schematic diagram A and schematic diagram B. the you can see. So the answer on the question A, write an equation. So my equation in equation A is a bar, b bar, c bar, open parenthesis, a plus d bar, close parenthesis. Then the b equation is a bar, d, e, open parenthesis, c plus b bar, close parenthesis. In the schematic diagram A, there are 5 outputs, 5 switches, 5 resistor, 4 inverter, and 2 AND gate. Oh, there's 3 AND gate and 1 OR gate. Then the LED. Then the schematic diagram B, there are 5 outputs or switches, 5 inputs or switches, then 5 resistor, 2 inverter, 3 AND gate, and 1 OR gate, and 1 LED. So let's proceed the actual circuit design in circuit design A. This is the circuit design A. So you can see, so the output Y is 1. So in the problem, in the equation 1, is this write an equation, design and develop a circuit for the output Y if we want Y to be 1 if the flow rate is less than 30 gallons per minute. So you can see, if we want the output Y is to be 1, so logic value 1 means is to lights the LED. So you can see there are 6 switches, but we needed 5 switches, and this is the AND gate, OR gate, and the inverter. 5 resistors. In the truth table, the A, B, C, D, E, and Y. So this is the Y, and the switches is the A, B, C, D, and E. So in the truth table, let A set all the switches 0 of the switches. So the Y output is 1. So the bulb will light on. Then next is the A0, B0, so A0, B0, C0, D0, so E is 1. So let on the A switches. So the Y output is 1. Then let's on the D switches. So the output is 1. So let's on the C 1, having a value of 1. So the output Y is 0. Then the B1, So the output y is 0, then all switches having a value of 1. So the output y is 0. So let's proceed the circuit design B, the actual circuit design B, and in the previous is the circuit design A. So let's proceed to circuit design B. Then you can see this is the design circuit in B, question B. So in the equation B, write an equation, design and develop a circuit for the Z if we want Z to be 1 if the flow rate is at least 20 gallons per minute but less than 5 gallons per minute. So if we all in the truth table, if we set all the switches A, B, C, D, E is 0, so the output Z is become 0. So you can see. Then if we set the switches E to switch on to having a value of 1, so the output Y is 0. So if the switches E become having a value of 1, so switch on. So you can see the Z output is 0. Then the D, so let's on the D. So you can see D. So the output Z is having a value of 1. Then switch on the C. Then you can see the Z having a value of 1, so the LED will lights on. Then the B, on the B, switch on the B having a value of 1. So the output Z is having a value of 1, so the LED will be lights on. Then the last one is switch on the E. So you can see the output Z is 0. So that's all. Thank you for watching of my videos.